Okay, this is LeetCode 1299, replace elements with greatest element on right side. So given an array, ARR, replace every element in that array with the greatest element among the elements to its right, and replace the last element with -1. After doing so, return the array. So initially, the kind of naive or brute force solution would be to, let's look at 17. Okay, to the right of it. So we start at 17, right? This first element. To the right of it, what's the greatest element in the remainder of the array? Well, that is 18. So then this would get replaced with 18, right? Okay, now let's go to 18. To the right of 18, what's the greatest element? That would be 6, so that gets replaced with 6. Now let's go to the next one. 5, what's the greatest element? That's 6, gets replaced with 6. Next one, also 6. To the right of 6, what's the greatest element? 1. Then this one, it says in the problem statement that we just leave with -1. That gives us our output that we get right here. Okay, so analyzing this solution, this would be first of all, we would need two loops, right? We need two nested loops, so we would do an iteration of all of the elements, and then among that loop, we would do another iteration to find the greatest element, right? So that would be of time complexity of big O of n squared. And then the space complexity, I believe, would just be big O of 1, or constant, because we're not storing any extra space. I believe that would be the time and space. Okay, so where can we make some improvements? So a lot of these questions, you can solve them a lot faster or a lot more performant by doing these kind of cool, like neat tricks, I guess. So what if we looked at it this way? What if we let me go ahead and erase these right here. What if we iterated from reverse? So starting at 1, this becomes we just set this to -1 because this is the last value. But at that point, the greatest value, or the greatest maximum value is 1. So then we go here and just replace this with 1. And then we'd also check to see what's the greatest maximum value, 6 and 1. Well, then the next greatest maximum value is 6. Okay, we go here. Does 4 exceed 6? It doesn't, so then this stays as the greatest maximum value, and we keep this as 6. Go to the next one. 5 and 6. What's the maximum between those 6? Keep this maximum value here. At this point, we would override this value with 6 as well, but then we would check 18 and 6. What's the greatest value? It would be 18, so this is our new maximum value. Okay, we go here to this next element, and we just replace this with 18 because that's our current greatest maximum value. We still get the same output, but in this situation, our new solution, we would have a time complexity of big O of n time, because we just do one iteration, reverse to start, right? And then the space complexity, would be big O of 1 as well, because we're just storing, we're going to use some extra variables, but those variables aren't going to, they're not going to grow in size as our input grows in size, so that will be fine. Okay, let's go ahead and try to work through this solution. So I'm gonna keep these on the, I'm gonna keep that on the right hand side, but see if I could go back to here. Okay, keep those annotations there to just give us some notes. So for this solution, we want to iterate in reverse, right? Okay, so we're gonna do, first of all, we're going to set the last value. Actually, we're gonna keep some values. We're gonna do cur value is equal to ARR at -1, and that basically just indexes the last value. So this would grab 1 in this case. And we're gonna do grand max is equal to cur value. So at this point, our grand max is equal to the last value. Okay. And we're gonna update. We're gonna do some comparisons in the loop to make sure that this gets updated as we go along. Okay, so we're gonna do AR of -1 is equal to cur value. No, it's actually equal to -1. So we're gonna set the last value, this last value, we're gonna override it with -1. Okay, and now we have our variables set up. So we have the cur value, we've stored 1, right? We've stored the value of 1, and then we've stored grand max. So at this moment, they're both equal to -1. Okay. They're both equal to 1, actually. Apologies about that. Okay, so we're just going to do a quick check to see, because there's some constraints. I believe the length of the array can be of length 1. Yeah, so we're just going to say if len of AR is equal to 1, then we're going to return the array, because in that case we would have already solved this case where there was just one element, and we can just return -1 by substituting it. Okay, so now we're going to get to the looping. So this is kind of the fun and a little bit confusing part. So we're going to create a for loop. We're going to do for I in range, and basically the range function takes the parameters it takes is a start, stop, and an increment value. So if we want to loop through this array in reverse, then what we're going to want to do is start at the end. We're going to want to stop at the beginning, and we're going to want to increment in reverse. So we're going to start at the end. So we're going to do length of array, and since we already substituted the last value, we're just going to do -2. And the reason being is that if we look at the indexes, let's see, about that. Let's change this to a different color. Okay, so I'm going to write the indexes in red right here. Okay, so this is index 0, 1, 2, 3, 4, 5, right? So since we've already done this last index, we want to start at the length of the array. The length is 6 minus 2. So 6 minus 2 would start us at this element. We don't want to overwrite this element because we've already done it with this statement right here on line 6. We've already overridden it to be -1. So we're going to start at element 4, and then we're going to end at the beginning, and we're going to increment by -1. So this value is going to start in the case of example 1, we're going to start at index 4, we're going to stop at 0, and we're going to increment by -1. So once this gets to 0, we're going to stop. Okay, so what do we want to do now, right? So we're going to Okay, let's grab the current value. So current value is equal to ARR of I, right? So grab the current value. Then we could, this is important that we do this first because we want to override it. But before we override it, we want to grab the value. So we're going to do, now we're going to do ARR of I, oops, ARR of I is equal to grand max. This is the overriding part. Okay, and now we want to recalculate our grand max. So we're going to say grand max. At each point, we want to check to say, is our grand max this new value? So in this case, we would update our grand max to 6, right? So we're going to do grand max is equal to current value. Actually, we're gonna do a helper function. We can use the function called max, and it's gonna, you just give it two values. So you're gonna do current value, comma, grand max, and this is just gonna return the maximum of two integers. So say we have 5 and 2, or say that we have 6 and 1. This is just gonna return 6. Okay, so that should be good. Once we return out of this array, or not out of this array, out of this loop, we still need to replace the first index, or the 0th index. So we're going to do ARR of 0 is equal to grand max. Okay, and then let's just return error. So we do this because the array doesn't actually replace this last index. You can test it out. You can't basically go all the way to the very beginning. It's a little bit of like a hitch. It can kind of be a little confusing when you're creating this, but let's see if I made any mistakes or if this works. Let's see, I messed up on here. I forgot the semicolon. Let's go ahead and run it again. Cool, yeah, so that's the solution. Yeah, so I don't know if I gave a good explanation for why we do this, but basically it happens to do with the range function. Basically, we stop at this element, and so we don't actually get to override it, so we have to do it one extra override once we exit the loop. And at that point we can return the array because everything has been overwritten. So yeah, so we've given the time complexity to be big O of n because we just do one iteration from the back of the array to the front. And if you want to get really technical, you could probably say that maybe we do big O of n minus 2. That might be a little complicated. I'm not sure if that's totally correct, because technically we don't iterate over this element, or we don't iterate over the front. We kind of iterate over the length minus 2. But I think if I were to give this an interview, if I were to answer this in an interview, I would say big O of n. And space would still be big O of 1 because we're just creating two variables, but these variables are going to be constant size no matter what our input size is. So the way I like to think of big O space is the amount of space that you're using, is it going to grow as your input size grows? If it does, then that kind of that's going to affect what you evaluate it as. Okay.